All right, more on basic probability. Just to follow up the previous video, uh, we ended off with defining a union of sets and the intersection of sets. So union of sets, the best way to think of it is just it's A or B. And the intersection of sets, the easiest way to think of that is it's A and B. So one way to visualize intersection and union is to look at a Venn diagram. So we've defined A to be the event A to be planned to purchase and B to be actually purchased. So the complement of A is they did not plan to purchase, and the complement of B is they did not end up purchasing. So if we look at this, if we look at the up here where I'm circling, this would be the A intersect B, which would be 200. Now, but let's look at the table and see how they came up with that. The intersection would be, again, we treat intersection as and. So they plan to purchase and they purchased. Well, that's going to be the number that is under yes and yes of both of the variables, right? So then we would have 200 people there. Um, didn't plan to purchase and didn't purchase would be at the intersection of no and no of both of these variables. So I think for obvious reasons, that's going to be 650. Now, the union of A and B is actually going to be 350, which we get by adding these numbers. So that would be the probability of B, which would be 100 over 1,000. Well, we're not doing probability, we're just doing counts. So the number in B would be 100. The number in the intersect of A and B would be 200. And then A, of course, is 50. So A union B would be equal to 350. Um, simple probability, simple event means that we're calculating the probability of a single event. So one example of an event from this table would be plan to purchase. Another event would be actually planned to purchase. Now, in the next slide, we're going to put these together and talk about joint probabilities. But right now, if we're just thinking about simple probability, we actually just end up working with the total rows. So as example, the probability planned to purchase, we can focus totally on this first row. No, I'm sorry, probability uh, of, okay, let me get this. So purchasing. So actually purchasing, plan to purchase would be uh, 250 people out of 1,000 plan to purchase. So the probability of purchasing would be 250 out of 1,000. Now, actually purchasing, we would shift gears and look at the columns because that's where actually purchase, yes or no, occurs. So we see that 300 people actually have purchased out of the 1,000. So the probability of that simple probability event would be 300 out of 1,000. Now, things get a little crazier when we start joint probability distribution. So that's where we start putting two things together. So the first example they've given is the probability of plan to purchase and purchase. Well, again, for reasons I explained earlier, that would just be the yes and yes response of both of the events. So that would be 200. If they plan to purchase and purchase, then that would be, I'm sorry, did not plan to purchase and did not purchase, that would be the 650. That would be the intersection of the no and no response of each of the simple uh, occurrences. So generalizing anything in a 2 by 2 table, anything, each of these components within the 2 by 2 table, not on the total rows. Those are called joint probabilities. And then any probability that we get from the total row is just called a marginal or simple probability. Now, let's pump the brakes a little bit and think about what we know so far about probability. Probability is just the likelihood of an event occurring. Probability must be between 0 and 1. Probability of 0 means it's never going to happen. Probability of 1 means it's always going to happen. Probability of 0.5 means it's going to happen day in, day out, about 0.5, about half the time. And the sum of the probabilities must always equal 1. So we get into a general additive rule. And the general additive rule for the union, so A or B, can be found by the probability of A plus the probability of B minus the probability of A and B. This just has to go in your notes somewhere with big old flashing neon lights around it. This is not intuitively clear. You didn't come out of the womb knowing that the probability of A or B can be found by adding and subtracting these 3 probabilities. It's just something you have to write down, and I'm going to teach you how to apply it. All right. Now, in a rare case where the probability of A and B equals 0, in other words, where we have mutually exclusive events, then the probability of A or B can be found by just taking the probability of A plus the probability of B. That's going to become much clearer, I think, I hope, through an example. So let's see how this plays out. So remember, I've restated the formula to find the probability of A or B. So let's calculate the probability of either planned or purchased. So the probability using the formula, we need the probability of A, which would be the probability of the first thing we're calculating. So the probability of planned, I would come to the yes column. This is a simple event, so it would be 250 out of 1,000. So that's this component. The next thing is a simple event. So I've got tunnel vision on again, the total. So the probability of purchased, I can look at the yes under purchased, and I can see that there are 300 entries there. So I have 300 out of 1,000. Then I have to come in and subtract the probability of planned to purchase and did purchase. Well, planned to purchase and did purchase is 200. So I subtract 200 out of 1,000. So if you do the math there, the probability of planned or purchased is 350 out of 1,000. Now, computing conditional probabilities is just a little more challenging, but still, if we have a basic understanding of how to calculate the probability of A and B and the probability of just a simple event, probability of probability of B, it turns out to be relatively straightforward. I think when embedded into an example. So a conditional probability is a statement where we calculate the probability given that something has already occurred. So this probability right here, where we have P, A, this vertical line B, this is read the conditional probability of A given that B has occurred. Now, to find that probability, we have to calculate the probability of A and B and divide it by the simple event of just probability of B occurring. Now, let's look at an example. So here's the formula. We have the probability of A given B. So we have to calculate the probability of A and B and divide by the probability of B. So we want the probability that someone purchased given that they planned to purchase. All right, so let's play it out. First thing we need to do is we need to get the probability that they purchased and planned. Well, that's the 200. So we have 200 out of 1,000. The next thing we do is we focus on either the column total or the row total. In this case, it's planned. So that's obviously going to be a row total. They plan to purchase as a simple event, 250 out of 1,000. So we're going to divide 200 out of 1,000 by 250 out of 1,000. So if you do that in your calculator, you get 450 out of 1,000, which turns out to be 0.80. Now, we can go even a little further. If the probability of A given B, if we have independent events, independent means when the probability of one doesn't impact the probability of another. If we have two events that are independent, then the probability of A given B will be the same as just the simple event of the probability of A. Let's take a look at that. So does the probability of purchased given that they plan to buy equal the probability of purchased? Well, we saw in the previous slide, 2 slides ago, that the probability of purchased given that they plan to purchase was 0.80. However, the probability of purchased is that's actually not right. This would be the probability of not purchased. So the probability of purchased would be 300 out of 1,000. So there's a typo there. I didn't create this, so we'll blame someone else. So anyway, the two probabilities are not equal. So these events are not independent, so they are dependent. Multiplication rule, again, these things just need to go into your notes. And when you run into these problems in my stat lab, either your exam or homework assignment, you just go through all of the different formulas and find the one that fits the need that you have. So again, we were given that the probability of A given B is the probability of A and B divided by the probability of B. Doing a little bit of arithmetic there, just dividing one side, actually multiplying both sides by the probability of B, we can see that the probability of A and B can be found by taking the probability of A given B times the probability of B. And if the A and B are independent, then the probability of A and B can be found by just multiplying the probability of A times the probability of B. So that really simplifies the calculation process of finding the probability of, again, A and B by just taking the product of the probabilities. All right, that's all I got. Take care.